Today we are solving the important question of the trigonometry. If x upon a sin theta plus y upon b cos theta is equal to 1 and x upon a cos theta minus y upon b sin theta is equal to 1, then we need to prove that x square upon a square plus y square upon b square is equal to 2. See, in this question there is a need of squarings. So let us squaring the both equations. Squaring this one and squaring this one. When we square it, we'll use the identity a plus b whole square. This is a squaring expansion of the first equation. In similar way, let us square up this second equation. We use in the first equation a plus b whole square identity, and the second equation we use the a minus b whole square identity. Now let us add these two equations. Square upon a square is common. Here y square upon b square is common. And see here, both are same magnitude but signs are opposite. One is plus, one is minus. So they will be cancelled. And 1 plus 1 will be 2. Now listen carefully. Sin square theta plus cos square theta is equal to 1. So instead of these two, we will write here 1. Sin square plus cos square theta is equal to 1. So instead of these two, we written here the 1. So x square upon a square, y square and b square is equal to 2.